Hi guys, what if I give you a long piece of paper and ask you to fold it multiple times and create a small square? We are going to do the same thing today. So our long piece of paper is our stream and we are going to use reduce operation to produce a single value. So without any delay, let's get started. What is reducing? So suppose we have a use case wherein we have to sum the elements of a list of numbers. Okay, so we have some list of numbers. So consider this is the variable name. Okay, so how do we do it generally with a for each loop? So we will instantiate some variable for storing the sum value as 0, and then we usually write some for each loop for each integer n in this numbers, right? And then what do? We do sum equal to sum plus x, or we can make it sum plus equal to x, right? So both are one and the same. So this way we do this operation. So in Streams API, we have something called reduce. Okay, so let us see that. With streams, how do we do it is we create a stream of the numbers and then we call reduce method. So now this reduce has two parameters. So first is the initial value. So we need two things, right? As we saw here. So we need some initial value and then we need this variable to store the the initial value, and then we need to have that operator, whatever operation we are doing here, we are iterating to to find the sum of the elements, right? So the operator as well as the initial value. So similarly uh, in reduce as well, we'll have some initial value and then we will have this binary operator. So what we are going to take, like the first element and second element, and what we are going to do with them. And so in this case, we are doing the sum, right? So if we see this internally, how this works is, so this is the initial value that we passed. Okay, so for this plus, now initial value is 0. So A is 0. Okay, so this is A and this is B, that is the first element. Okay, so 4, 5, 3, 9, this is the stream of integers that we have as input. So A plus B, so A is 0 initially as we defined, and then B is 4. So A plus B, okay, is stored. So 0 plus 4 is the next initial value. So now in the next iteration, this becomes A plus B. Okay, sorry, this is B here, A plus B. Okay, and this is the addition, and now this becomes A and then this becomes B. Okay, A plus B, 4 plus 5, 9, and now 9 becomes A and then 3 becomes B. 9 plus 3, 12, and then 12 becomes A, the result becomes A, and then the next element B, and then we have the final result, that is 21. Okay, so there is another constructor for reduce. There is another method which does not take any initial value. So if you don't want to pass any initial value, you can use this. But this doesn't return an integer, rather it returns an optional value, because suppose if the stream is empty, then what do we return, right? So that is why it returns an optional, and we have already discussed a bit of optional in the previous video. Okay, more detail of optional we'll discuss in future videos. Okay, so this way the reduce operation works. So suppose if you want to find the max integer value in this stream, so suppose you have this 4, 5, 3, 9, and you want to find out which is the max value out of these. So now instead of summation, here what we are doing is we are doing integer map, right? So instead of, suppose if you are not comfortable with method references, but I believe you should be comfortable. So instead of this, we can also use something like xy. If x is greater than y, return x, otherwise y. Okay, some expression like this if you're not aware of integer max reference. Okay, so in this, how the internal flow happens, right? So here we have, if we look at this xy, so this is our x, and it will take the first element and the next element. It will find out which is the max value out of these two. So 5. So that is stored as x again, and then the next element is y. So out of 5 and 3, which is the max? It is 5 again. So that is the x, and then the next element is y. So which is max? 9 is max. So in this way, internally it does the iteration and then performs this operation that we provide to it. Okay, and as there is no initial value here, that is why it returns an optional, and then from this optional we can get the value if it is present. So suppose if you have a use case wherein consider this question. Okay, so suppose if we have discussed in the last videos, right, we have a list of dishes, and then so you have a menu wherein you have a list of dishes and you have to count the number of dishes in a stream. Okay, so count the number of elements in a stream. So if you are already using already working with Java, I believe, so you already know about the count method, but today we will not be discussing the count, but we'll be discussing using the map and reduce methods. Okay, so this is a kind of a pattern, map reduce pattern, which is used mostly for the search engines like Google. Okay, so what we do here is we are first creating the stream and then mapping each element, or rather counting each element as one. So suppose you have x number of dishes or x number of objects or whatever. How do we as a child, how do you count? 1, 2, 3, 4, 5. So right, so here each element we are giving it a number as 1. This is 1, 1, 1, 1, 1, and then we use the reduce operation and then we add up all the ones. Okay, this is 1 plus 1, 2 plus 1, again 2 plus 1 is 3, 3 plus 1, 3 plus 1 is 4, 4 plus 1, 5. So totally we have 5 objects here, or 5 dishes, right? So in this way we can use map and reduce method to count the number of objects in the stream. Okay, we directly have a count method as well, which we will discuss in the next videos, but this is the way to use map and reduce methods, right? And this is called a map and reduce pattern. This is beneficial mainly if you want to take the benefit of parallelism, because the internal iteration is happening internally. And if you use the for loop wherein we have some variable, so when it comes to parallel operations, it becomes very difficult, and again you have to use the synchronized keywords and all that things, right? If we are doing external iteration using for loops. But if you use streams, internally it handles everything, so you don't have to worry about parallelism. But there is one catch when we want to create some parallel streams. We shall discuss more about parallel streams in later videos. So the one thing that I want to mention is the whatever the lambda we use to reduce, okay, this lambda expression, whatever lambda expressions we use in parallel stream, they should not be changing the state. Okay, their state, whatever variables we use within the lambda expression should not change the state. And also order should not matter. It should not matter whether I'm doing a plus b or b plus a. Okay, this order should not matter. And also it should not be some variables, like it should not have some instance variables, because their state can change because they are associated with that instance, and then some other thread can change their status. So there are some rules for parallel stream that we will see in the next videos. Okay, so this is just the basic idea which I have given for parallel stream. So now let us see the stream operations which we have already gone through till now, right? We have gone through map, filter, reduce, sum, max, sorted, distinct. Okay, we have gone through these stream operations from the last couple of videos, and let us see what is meant by stateless and stateful for these stream operations. So when we consider map and filter, what do they do? Right, as we told, they take they take each element from the stream, do some operation on it, and then produce the result 1. Then they take the next element, produce apply the same function or expression over it, and then produce the result, right? So they kind of so these are kind of independent. So if you see the first and second, they are kind of independent to each other. 2 doesn't need to know what happened with the first element, how it got mapped. Then similarly 3 doesn't have to know what happened with 1 and 2, how were their map or what their results were. So these are kind of stateless operations, right? Okay, the map and filter. So also it doesn't matter what the operation was applied to the previous elements during the processing of these elements. Okay, so these are stateless. But operations like reduce, sum, max, they need to have some internal state, right? So as we saw now, reduce, okay, so we had some numbers, suppose 4, 8. Okay, if you're saying reduce it or find the sum or find the max, you need to know the relation. So if you have done 1 and 2, you will get sum as 3. So then you need to store this somewhere. You need to know the previous state. Now in the next iteration, when you take number 4, you need to know what happened in the previous iteration, right? The previous iteration result was 3. So you need to know this. So this is kind of a stateful operation. Okay, each iteration is not independent of the other iterations, but they have to know the state of the previous iteration, right? So, and also here we are storing just, so this when we consider space requirement, okay, so here we are just storing one attribute. Even if you're doing sum or max, you just store the one. So whatever your input size may be, suppose you have 1000 elements, so in each iteration you are just going to store one. It doesn't matter on the input size. Okay, that is one thing which we can remember for this. So that is the internal state, right? Internal state is of bounded size, like you don't have, the internal state doesn't change with the number of elements in the input, right, for reduce, sum and max. But now when it comes to sorted and distinct, what happens? Initially it seems like sorted and distinct is just like map and filter, it is just taking and filtering out, but no, right? So when coming to sorted, you need to load all the elements of the stream, and then you start doing your operation, right? You need to know the previous history, previous iteration history to do their job. They need to know the previous iteration history. Also, how about the storage requirement? How about the space requirement? Suppose if you have something like reverse all the prime numbers, is it possible to do that? Do we have a finite set of prime numbers? No, we cannot do that. So here it is an unbounded state. The state can change, or not can, the state will change with the input. Right, so the state will change with the input. If the input is more, then also the space requirement also will be more. And also as it also depends on the previous iterations, so this is also a stateful operation. Filter and map which operate singly on each element, they are stateless, but operations which need to know the previous iteration result, those are the stateful operations, right? And also sorted and distinct, the operations which need to know the entire input, they are in an unbounded state. I mean, based on the input, their space requirement also would be large. So we have seen a lot of intermediate and terminal operations. Let's quickly go through these. So first is the filter. So it is not an terminal operation, it's an intermediate operation. It returns a stream and then it takes input as a predicate. And that predicate, it has this function descriptor, any type, and it applies that predicate and returns the boolean, right? Distinct is also an intermediate operation. It is stateful and unbounded. Okay, it returns a stream because it is an intermediate operation. And skip is also intermediate, stateful and bounded, right? And its return type is stream, and it takes along as input. Limit is also intermediate, stateful and bounded, right? And then its return type is stream, and then its type is long. It returns the limit of the how many elements the stream should have. And skip, it tells us how many elements you have to skip. So their internal state is not unbounded. We know how much we have to skip, or we know how much our result should have. Okay, and then map is also an intermediate operation. It returns a string and it takes a function with some type and return value as the input, and its function descriptor is, it takes this as input, this object, and returns this. Okay, and this function is applied to each element of the string, and it creates a new stream and then returns that stream. Similarly, flat map, it is also intermediate, just like a map, and then it takes a function that is of type t and stream as the input. So as we have seen in the last video, it works on stream of streams and creates a single stream, right? It takes some object as input and it creates a stream of the return values. Sorted, it is also an intermediate, and it is unbounded because based on the number of elements in the string, it works, right? The storage requirement will be based on the input number of values in the input. So here the return type is string, and it needs a comparator obviously to sort two elements. It takes two elements and it returns some integer, either 0 or 1 based on the comparison. And then any match. So now we are seeing all the terminal operations from here. So it will return a boolean whether to say true or false, whether the element was found or not. Okay, any match. So it takes some predicate condition and it returns a boolean. Similarly, none match, all match, and then find any. Okay, so these four are similar, but find any, it will return an optional. It has to find an object, right? So it returns an optional, and find first will return the first object that is find. So these are optional, and then if they are present, we can check if present or is present, and then we can get the value from this optional. And we all have also seen for each, collect, reduce, and count. So these are also the terminal operations, and here reduce is bounded, so it just stores one value in the intermediate operation. In its internal iteration, it just stores one value. Okay, for each, it doesn't return anything, it applies it consumes whatever we have given to it, right? So this is the argument, and it consumes that consumer definition which we have given, and it doesn't return anything. So something like if we are just printing out system.out println. So suppose we are creating a string dot for each, and then we are just printing each, we are just consuming each element, something like this, not returning anything. So collect, so its return type is the object, like we have done toList, toSet, right? So this is the widely used terminal operation, because we generally do toList. Okay, and it needs a collector as input. Okay, as we do collectors dot toList. Okay, type, argument, and the return type. Okay, and reduce operation. So this is also a terminal operation, bounded. I think we have already discussed. Its return type is optional, and it takes a binary operator. It takes two arguments and then returns and has a return type. So if you are passing in two strings, string 1 and string 2, it will return string. If you pass two integers, it will reduce them to give one integer. Okay, so it is of the same type. And then count, it's straightforward, it returns long. So for the next video, I'll be posting few questions, and I would like you guys to work on it, and we will see the results and how to write these expressions in the next video. Okay, I'll be posting the questions before the video, and you guys can look for the answers and be ready and check the answers in the next video. That's it for this video. Thanks for watching. Bye.